please to remember, man. I keep forget the things like recording. Okay. Okay, so there are some of the important definitions or some of the important terms, basic terms, in fact, you can say, which you need to understand so that you can understand the concepts of the second law. Okay, let us see one by one by one. Okay, the first one is the thermal reservoir. Thermal reservoir is just you can think as a tank or just a box, whatever in your imagination you can think as a certain region of space where it has an infinite capacity of heat storage. Got my point? What is a thermal reservoir? It is whatever it is. It is a bath, you can say. You can place a region, you can say, okay, or a tank, you can say, okay, where it has a capacity. So how much amount of heat you give to the system, all the heat it can absorb it and keep it for you. Okay, it is just like a bank, a thermal bank, a heat bank, you can say, where it can store your heat energy how much ever you give it. So infinite capacity it has. So that is what I want to say. Infinite heat capacity storage. Similarly, infinite heat capacity emission. So how much it has stored, the same amount it can replenish whenever it is required. So that is what the concept of thermal reservoir is. That okay? Can anyone just read it out? What is thermal reservoir given here? Numan? Manasati? Ashwin K.A.? Ashwin? Rohan? So all these guys will be marked absent.
Yes, sir.
Rajat?
Sir.
Rajat, yes. Read out what is thermal reservoir. Thermal reservoir. What is thermal reservoir? It has been given in the, I think, presentation is visible. So just read it out. This part here.
Sorry, sir, I cut the call by mistake instead of unmuting myself.
I'm audible, by the way.
Sir?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine, no issue. But I'm audible. That's my question.
Yes, sir.
Yes, sir.
Since many of them are not audible. Okay. Yes. Can anyone just read this out, man? Thermal reservoir. What?
A thermal reservoir, also thermal energy reservoir or the thermal bath, is the thermodynamic system with the heat
Yes.
capacity so large that the temperature of the reservoir does not changes when a reasonable amount of heat is added or extracted.
From the system. Okay. So see, this thermal reservoir will be maintained. This point I forgot to say. A thermal reservoir will be maintained at a given temperature. Say my reservoir is maintained at 45 degrees centigrade. Okay. So if I fix that particular value to a thermal reservoir, then that value should not change of heat. Next, coming to the source. So even source is also a thermal reservoir, where source in the sense you can by the meaning of it you can understand it that source is nothing but it gives infinite amount of energy out of the system. That means it provides the heat energy from the reservoir. So reservoir which has the infinite amount of heat can be called as a source. Can anyone just read the source? Shabat?
Yes, sir.
Source.
There must be the source of heat of infinite thermal capacity, and that should be at a constant high temperature so that If any amount of heat is withdrawn from it or given to it, that does not affect its temperature.
Mhm. Got the meaning. Next is working substance. So working substance is the substance which takes the heat and gives out the heat to where usually two things. And this particular diagram which I am drawing now will be repeated all throughout your second lab. So please pay attention. Okay, so this I will call it as source, which gives out the heat, and the other there is there we will come across in the near future, which is known as a sink, which can absorb any amount of heat. The source is that particular thing which can absorb any amount of heat. The source is that particular thing which can give out any amount of heat, whereas the sink is the constraint that very important thing. So source can give out heat, sink can take heat, subjected to the constraint that temperature of those reservoirs should not change. Okay, so this is the thing. So in this particular backdrop, the heat engine will come into picture. So this is your heat engine. In this heat engine, what does it do? So it takes out heat. So let me say Q1 amount of heat is being drawn from the source. Q1 amount of heat is being drawn from the source, and Q2 amount of heat. So heat engine, what does it do? It draws Q1 amount of heat from the source, and Q2 amount of heat it just throws away into the sink. Now, heat engine in the sense it gives us the work output, is it? So heat engine in the sense it gives out the work output, and this particular work output from the heat engine will always be the difference between these two values, that is Q1 and Q2. That means if you want to increase, just by looking at these expressions, you can say if you want to increase the work output, you have to increase the heat which is inputting into the heat engine. Is it? So you have to increase the amount of heat. That means you have to increase the Q1. Parallelly, what you have to do, you have to decrease the amount of Q2 so that whatever heat you are providing into the system is being converted in the form of the work output. Is converted in the form of the work output. So nothing goes out of the system. So you have to reduce the value of which is going is just converted. Okay, so the Q2 value should be low and the Q1 value should always be higher, so that your heat engine will give the maximum work output. Okay, got the concept of this, everyone?
Yes, sir.
Any doubts here?
No,
Any doubts in this concepts of sourcing, heat engine, and its work output?
No, sir.
Okay. Okay, sink. Can anyone just read out the sink? Sink. Niharika. Niharika. Doctor. Reza. Mohammed Reza.
yes, sir.
Mohammed Reza.
Yes, sir.
Niharika, I think there is a voice disturbance from your side. Your voice is not heard properly. Okay.
So your voice is breaking, sir.
Okay, so
Yes,
is
sir.
that issue with everyone?
Yes, sir.
Everyone has that issue.
Yes, sir.
Okay. Okay. Whenever such issues come across, you just put a message in the chat box because I'll come to know. I'll just change my connection. As now I am not in the college. I am in my hometown presently, so that there could be the fluctuations in the internet. So please do
Sir.
notify me whenever
Hello.
such problems arise. Okay.
Hello, sir.
Till now, okay. So
Sir, at
till
10:15
now,
we have an
thermal
inaugural for
resin
Mac.
like the sourcing, heat engine, those concepts are Karthik, yes.
Hello, sir.
Yeah. I will
Hello.
leave it out. Just give me 2 minutes more. Okay.
So there is a disturbance, sir. There.
Yep. Yeah, I got it. Sorry for that. Okay. Just give me. Am I audible, man?
Yes, sir. Now it is clear.
Okay, fine. So I think there is some municipality this thing in front of our house. So there is a background disturbance. I know that. So better what you will do, you'll take the attendance in the next class. Okay. And end
Okay,
up the
sir.
class time. So 11 o'clock you have that inaugural function, is it?
Yes, sir.
Okay,
Yes,
guys.
sir.
Okay, guys. Just remind me in the next class to mark the attendance for the present class. We'll do it in the next class. Okay. Till then, have a nice day. Take care. Okay.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.